Projectile Motion Series M&M Quiz 2171. Welcome to hecanhelp.com. Welcome back. At t is equal to 0 seconds, a projectile is launched from point A as shown at 32 meters per second magnitude and 30 degrees with respect to the horizontal. So here is your vector, 32 meters per second, and the angle with respect to the horizontal is 30 degrees. Assume no air resistance and constant acceleration. What is the horizontal displacement AC? What is the horizontal displacement? Basically, we are asked for this distance. What is that? What is the horizontal displacement AC? Is it A, or is it B, or is it C? Points A and C are at the same height. What is the equation for displacement along the horizontal? Displacement along the horizontal is initial velocity along the horizontal times time to go from A to C plus 1/2 acceleration along the horizontal. Acceleration along the horizontal is 0. It is a projectile. Acceleration along the horizontal is 0. There is no pull or push along the horizontal. So because of that reason, the acceleration along the horizontal is equal to 0. What does that mean? That means your horizontal velocity component will remain the same forever. So this whole thing is equal to 0. What is left? So when this whole thing is equal to 0, what are we left with? Displacement along the horizontal, delta x. This is delta x, okay? And that is delta x. Displacement along the horizontal is equal to velocity along the horizontal at the start times time to go from A to C. Velocity along the horizontal at the start is 32 cosine 30. Why? You have 32 meters per second hypotenuse. The x component is 32 cosine 30. The y component is 32 sine 30. The x component is unaffected by gravity. The horizontal component remains a constant. The vertical component changes. What is the displacement along the horizontal? It is velocity along the horizontal, which is 32 cosine 30, which is 27.713 meters per second, times time to go from A to C. So all we have to do now is get the time to go from A to C. To get the time to go from A to C, we know that between points A and C, delta y is equal to 0. So A to C, delta y is equal to 0. So let's look at that equation along the vertical. Delta y is equal to initial velocity along the vertical times time plus 1/2 acceleration along the vertical times time squared. Point A and point C are at the same vertical height. What does that mean? It means that change in y between points A and C is equal to 0. We also know the initial velocity along the vertical, and that is 32 sine 30. 32 sine 30, and that is 16 meters per second. We don't know the time. Acceleration along the vertical is negative 9.8 because positive x is defined as 2 to the right, positive y is vertically up. Again, time squared. So you get change in y between points A and C is equal to 0. We initial y, which is 16, times time to go from A to C, plus 1/2 acceleration along the vertical times time squared. Divide throughout by time and you get 0 is equal to 16 plus 1/2 negative 9.8 times time. 1/2 of negative 9.8 is negative 4.9. Negative 4.9t, when you take it to the left, it becomes 4.9t. and you set it equal to 16, divide both sides by 4.9, and you get t is equal to 3.265 seconds. T is equal to 3.265 seconds. What is this time? That is the time to go from A to C. So now we have the time to go from A to C. We also have the velocity along the horizontal. And because velocity is a constant, all we have to do is multiply velocity along the horizontal times time, and you get the displacement along the horizontal. So we have delta x. So delta x is equal to initial velocity along the horizontal times time. Initial velocity along the horizontal is 32 cosine 30, which is 27.713. Time we just found out, 3.265 seconds. So velocity along the horizontal times time, meters per second times seconds gives you meters. So that's what we have here, 90.48 meters. So what is the horizontal displacement between point A and point C? It is 90.48 meters. And this is George Mathew, always wishing you the best. Good luck.